Okay. I decided to split the differential equations part 2 into two sections because it turns out I didn't want to make them more than about 20 minutes long, even though I'm covering almost sometimes a month and 20 minutes of normal differential equations class. Okay, so this is part 2B, we'll say, of differential equations lecture. And here we go. In the last, in part 2A, we were discussing exact equations that are not initially exact. So let's take a look at another example. If we try the test my equals nx on somebody gives us this differential equation to solve. My, this is m right here. My will be 2x. And this is n. And nx will be negative 2x. So no, the exact test does not work on this differential equation. This is not an exact differential equation, but maybe we can transform it into a differential equation. It turns out that Formula 1 in part 2, my part 2 lecture, will fail. So I'm just going to go right to Formula 2. You can test out and show, I have an example on my, in my part 2 lecture, of the formula, using the Formula 1 that doesn't fail. This one will fail the Formula 1. So we'll go on to the Formula 2. This is Formula 2. From my previous lecture, and it says, do you know nx? And yes, I know nx. It's negative 2x. Minus is a minus. Do you know my? And yeah, I know my. I said that over here. It's 2x. Can you do a little bit of algebra to this and simplify it? Yeah, I'll get this. Oh, look, it's only a function of y. If it turns out to be only a function of y, then this is an exact equation. We just have to find an integrating factor. So our integrating factor, we had a formula that I gave you is mu equals, the integrating factor equals e to the integral of g, and g is this function that we found here, negative 2 divided by y. Mu equals this, and this equals this. The integral of this is this, and if you do a little bit of algebra, you get this. So mu equals y to the negative 2. And just like I did in the last example in my part 2 video, we take the mu and we multiply it times the given differential equation we were given to solve. So here's y to the negative 2 times this. And if we do a little bit of algebra, we get this right here. Do a little bit of algebra. We get this. Now we're going to test again if it's an exact differential equation like we did in lecture number 1 of my videos of differential equations. So again, this is m, and this is n. And do you know my? Yeah, the derivative of this with respect to y is this. Do you know nx? Yeah, the derivative of this with respect to x is this. And this does equal this by algebra. And so that means we changed a non-exact differential equation into an exact differential equation. So once we have an exact differential equation, we can use the method we have in lecture number 1, phi equals the integral of m dx right here. Do the integral of this with respect to x, you get this right here. And then we take the derivative of this, partial derivative with respect to y, and the partial derivative of this with respect to y is this, of course, right there. And then we set it equal to Mr. N over here. So here's Mr. N, and I set this equal to Mr. N right there. And then we need to solve this differential equation right here. These two will cancel right there. And we'll get f prime equals 1 if those two cancel. Bada boom, bada boom. And if we do the integral of f prime, we get f. The integral of this, remember, it's with respect to y. This is a function of y. So the integral of this with respect to 1 is y is y. And plus as some constant. And so now we have the solution to this differential equation, or this differential equation, either one or both the same differential equation, and the solution to this differential equation is actually up here. It's x squared y to the negative 1. There's x squared y to the negative 1. Plus, do you know who f is? Well, yeah, I did a bunch of work to find out that f was equal to y plus c. So f here is equal to y plus c. So plus f plus y plus c. So this is the solution to the this differential equation. And I did a little bit of algebra if you like. This is the solution, but if you want, you can write it a little bit prettier like this. Alrighty. Now, sometimes an exact differential equation will fail all three tests. I'm only going to show you one of the tests, my and x. Are these equal? This is my will equal 2, and x will equal negative 1. So that fails my test in lecture number 1. I'm not going to go through the other tests that it would fail. I'm saying that it will fail. It'll fail this test also. It won't be a function of y necessarily, and it won't be a function of x necessarily. So we have a different method for solving this differential equation here, and that is to transform it into this equation right here. So let's try to transform this into this, okay? So let's go. Do you know who Mr. P is? No, I don't know who Mr. P is. How about Mr. Y? I'll just leave him alone, Mr. Y. Do you know who Mr. N is? Yeah, it's negative x right there. Okay, then plug that into there. Mr. N is negative x. Good job. Do you know who Q is? No, I don't. How about Mr. X? I'll just leave Mr. X alone. Do you know who Mr. M is? Yeah, Mr. M is right there. I do know Mr. M. Just like I knew Mr. N. Equals. There's the equals. X times y. Do you know who my is? Yeah, I do know who my is. I actually did it over there. It's 2. Minus. Do you know who nx is? Yeah, I do know who nx is. I did it right there. It's negative 1. Good job. You have transformed this differential equation using this equation into this differential equation. Okay. If we do a little bit of algebra, we'll get this right here. There is, if we notice, there is no x squared term on this side. So that means that q has to be 0, because you can't have an x squared term here and no x squared term here. Q would have to be 0. And if q is equal to 0, that means that this island is also 0 right here. So these two will cancel out, and we'll get a negative p yx equals 3xy. And if we cancel the y-x's, I think we'll discover that Mr. P equals negative 3. And like I said before, q has to equal 0. So we've solved. Remember, we didn't know who Mr. P or q is? We found out who Mr. P and Mr. Q are. The next thing we'll do is we'll assume that our integrating factor, what we have to multiply this by, like we did the last two examples, is x to the p times y to the q. So let's see who our integrating factor is. Do you know Mr. P? Yeah, he's negative 3. Okay, then here's the x to the negative 3. Do you know who Q is? Yep, he's 0. Okay, then y to the 0. So we're assuming that. So we assume that mu is equal to the integrating factor is x to the basically negative 3. that that'll be our integrating factor. Let's see if it is. What we're saying is take this integrating factor, just like we did in the last two problems, and multiply it times your original equation. Well, here's this person is right here, and here's this differential equation right here, and I'm going to multiply it in. And when you multiply it in, you do a little bit of algebra, you will get this. And what we're saying is, we think this is going to be exact. We think it will pass the test. Let's see if this passes the exact differential equation test. My equals nx, just like we had before. My is 2x to the negative 3 is the derivative of this, because this is m right here. And this is Mr. N. And nx is equal to 2x to the negative 3. The derivative of that is equal to this with respect to x. The derivative of this with respect to y is this. And look, they're both equal. That means the exact test that I taught you in lecture number 1 of differential equations works. That means this is an exact differential equation. We've changed that equation from not being exact into an equation that is exact by having to do all this stuff right here. So how do we solve this? The same way that we solved in lecture 1 and lecture 2. Phi equals the integral of this dx. The integral of this with respect to x is this right here. Then we take the derivative, partial derivative of this with respect to y. We will get this right here. That's the partial derivative of that with respect to y. And then we set that equal to Mr. N over here, negative x to the negative 2 is right there. And then our job is, can we solve this differential equation right here? Can we solve that for Mr. F right there? Well, these two guys cancel. Bada boop, bada boop. And we get f prime is equal to 0. And if we do the integral of f prime, we get f, and the integral of 0 is a constant. And so, lo and behold, we do know the answer to this differential equation. It was actually sitting right here. So here's this person right here. This island is here. I'm going to make this a little bit bigger so we can see that this is 2 islands. This island is this island right here. Plus, do you know who Mr. F is? Well, yeah, I did a bunch of work here, and I found out that F was equal to C. So plus F plus C. So in for F, we'll put a C. And this is our solution to this differential equation. All right. All right. Let's look at something called the Cauchy Euler equation. This is the form of a Cauchy Euler equation. It will have some constant x squared. X squared is 2 derivatives. X to the 1 is 1 derivative, and x to the 0 is 0 derivatives. So then you'll have constants and some sort of function of x over here, of course. Okay. We will be doing a substitution of x equals e to the t in this equation. I'm not going to show you that transformation. It'd take 20 minutes just to do that. So I'm going to show you the generic formula. We have to transform this into this formula. So our step number 1 will be, once somebody gives us a differential equation, we'll change it into this differential equation. Step number 2 will be, we will solve this differential equation. And step number 3 is, we'll undo this substitution by plugging in t equals natural log of x. So these are our 3 steps that we're going to do, okay? So let's look at an example. Here's an example of a teacher giving us our book, giving us this differential equation to do. Notice it's got x squared y double prime, x, y prime, and x to the 0, y. So this is a Cauchy Euler equation. We have never solved any problem like this before in my lectures. So these are brand new types of equations. The first thing we need to know is who is A, B, and C. Who's A, B, and C here? A is the number in front of the first island, which is 1. There's A. B is the number in front of the second island, which is -1. Right there. And C is the number in front of the third island, which is 5 right there. So that's the first thing we need to figure out, because once we know A, B, and C, I think we can do step number 1. Let's try to do step number 1. Step number 1 says, do you know Mr. A? Yes, I know Mr. A is 1. So he says put a 1, then put Y double prime, then put a plus. Then do you know who B is? Yes, he's -1. There's -1. Minus, do you know who A is? Yep, A is 1. So in for A, put a 1. So we get this for B minus A. Who's Y prime? He's Y prime. Plus. Do you know who C is? Yep, I know who C is. He's 5. There's a 5. And there's Y, and equals, and then whatever you had a function of. We're doing an easy Cauchy Euler, so we don't spend too much time, but you could do more complicated ones with this. But you need to find your function here and plug wherever there's an x, plug in e to the t. So if there was a sine of x here, you'd write here sine of, if this was, let's pretend it's sine of x. Over here you would write sine of e to the t. That would make this problem amazingly complex and take another half hour to do it. So we're not gonna do a complex problem here, because we're not here to do every single problem possible. Try to keep the lectures a little bit short for you guys. If people love these differential equations lectures, I'll do more of them, and we will do problems that take half an hour to do. Anyways, so who is our function? Our function is 0. So we'll put e to the t wherever there's an x. There is no x's, and so we'll get 0. So this is our generic formula. We transformed to this generic formula. This is our example. We've transformed it into this this differential equation right here. This differential equation we have solved. I think we even solved it in lecture part number 1 of my video, my first video. The solution to this is transforming the derivatives into r squares, r's, and this, and so this becomes this. Solving this with algebra. If we solve this with algebra, we'll get a 1 plus or minus 2i. Is the solution to this, gives us the roots of this. And once we have that, we can write the solution here, as I've explained before in my other lectures. You put the real part on the e function, and you put the imaginary part inside the cosine and sine function. So the solution to this differential equation is this solution right here. Okay, so we've done step number 2. We've solved this differential equation. We did step number 2. All we have to do now is step number 3, which is plug in t equals natural log of x, which is of course the opposite transformation of algebraic transformation of. If you solve that for t, you get this. So t equals natural log of x. Let's look around for Mr. T. There's a Mr. T. Put in a natural log of x. Well, of course, e to the natural log of x is equal to x. So e to the natural log of x is equal to x. So that becomes that. There's the y equals. That becomes that. There's the a. There's the cosine. 2, do you know who Mr. T is? Yep, we said we're plugging t equals natural log of x. So in for the t, put a natural log of x. Plus b sine 2, do you know who t is? Natural log of x. So this is the solution to this Cauchy Euler differential equation. Okay. And you know what? That's the perfect time. Here's a preview of part 3, which we'll do, but that's 20 minutes, and I think that's long enough.